Hello there, today we'll be doing the bonus problem using the UMPIRE method. This problem is called the destination city. In this problem, we are given a path and we need to find the destination. The destination is defined as a city that has no other possible destination cities. So you can't go from this city to any other city. So that means, from my understanding, we can see that it cannot, once we arrive at the city, there will be no other cities to look at. Okay. So this calls for a pretty nice hash map type problem where we just insert the destination city as value and to city, start city, to be as key, and if not in if destination city not in hash map, then we have our destination city. That means this city cannot go to any other city. So let's look at some edge cases. Looks like we are looking at strings. Can we have a path that does not exist? Like, will there always be a single path with a destination city? I think so. And the answer is yes. I think that will there be a single city from multiple cities? I think yes. That what I mean by that is, i.e., like we have A to E and we have B to E, but I don't think that matters all that much, or V to E at this point, because I can't type a B and E to B, right? So that's possible. Anything else? So knowing that there will always be a destination city, there will always be a single path. Yes. Anything else that we should know? Yeah, I think that should be good. That's enough clarifying questions. Let's just look at the method. And the method was hash map. One other method that I can think of right now is to just traverse through the entirety of the paths. And that's to write a function that will save us space. If we look at this item, we can check if any of these items have b in it, but that would cost us n times n time. So that would be poor on O of n squared time. But if we use the hash set, it will be O of n because we'll just be looking it up immediately. So we'll go with the hash map. We're looking at a O of n runtime, and we're looking at O of n space. All right. So with that, we're ready to look forward into our planning. So the plan was, or is, create a hash map of the destination from city to destination city, and 2, check if destination city in from city. If not, then return destination city. All right, well, that's good. Let's implement it. So definition, find destination city, and we'll look at paths, and we'll return a string. All right, looks good. So what happens here is that we're gonna look at create a hash map, or hash map, and that's gonna be empty at this point. So we're gonna put items into it. So I don't know if you can do this, but let's try it. For destination and from, well, start and destination in paths, we'll take a hash map of this start, and we'll go to our destination. So for destination in hash map values, if destination in hash map not in hash map, return destination. Okay, with that, we can do some review if this works. I'm not sure if this code is up to par. Let's run it just to make sure. Okay, let's just test out one of these examples. Let's try the first one. Output should be Pablo. Print. This is our path, and we're gonna find destination city paths, and it worked. So we found our St. Pablo, which is our ideal solution. And let's check the next example, and so on and so forth. I think this will also work. It will return A. Now let's check multiple, like let's say this returns C as well. I think that would also return A. So I think it checks out. A single path would also return Z. So I think that's it. So with that, we have solved the problem. And let's evaluate. It was gonna be, and the runtime is going to be O of n, because we did go through all the paths and we are going through them a second time. So O of n. And space is O of n because we store paths in hash map. Alright, with that, we are done with this problem. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. And if you have any questions, please comment. Thank you very much. I'll see you in the next one.